Hello guys, welcome once again to another YouTube tutorial session. This session is a continuation of the Python programming series, and I release a new video every Tuesday. You can also check the various sections of this video by clicking on the links in the description below. So today's session I'm going to talk about strings and how it can be used to manipulate DNA sequences in Python. And we are going to cover these points that are listed in the screen. So we have the creation of a string, and we also have codes to create DNA sequences, and we also learn how to convert DNA sequences into upper cases or lower cases. And then we also go ahead to write codes that can determine the length of a sequence or a string objects. And then we also check for the presence or absence of characters or nucleotides in strings and then sequence objects. We are also going to look at how to count the number of nucleotides or some other patterns in a string objects. And then we also look at combination of strings and sequences. So we write codes to combine strings or sequences that are in different objects. And then finally, we'll end the tutorial by performing a short exercise. So first, let's look at how we are going to create the strings in DNA sequences. So as I indicated in the previous tutorial, strings are created by using the double quotes or single quotes. So let's just say we have a string. Let's say my name. Okay, we assign it. So my name, or let's just use the YouTube channel BH Computing. So this is a string. Okay, so we can display this here. So it prints it out for you. Now, so far as the characters are in quotes, it's a string. It doesn't matter the contents in it, whether there's a space or there's a dash or any character. Once we have this double quotes in it, it becomes a string. And we can actually confirm this by using the type command. Okay, so that's a string object for us. Okay, so that's for string. Now let's create a DNA sequence here. So let's just say DNA, then we can just issue here. Let me be consistent and use the double quotes. So this becomes a DNA sequence. Okay, so I can print that DNA so the DNA sequence has been printed. Let's create another object. So let's just say DNA2 is equals to AGTCCCA. Okay, so we can print it as well. Okay, so that's for creating of DNA sequences and then other strange characters. Now let's do a final one where this time I say my language. Okay, so this is also a string, and we can print it here. Okay, you can also directly print the string object without having to assign it to a variable. So let's just say print hello world. Yes, this should have been done in the first line, but yes, so hello world means you are greeting the programming world. Okay, so there's also another strange creating code. Okay, so now we'll quickly shift to the conversion of the strings or DNA sequences into lower or upper cases. Okay, so you'll do this by still using the previous strange objects we created. Let's say here's DNA2. Okay, so you can see DNA2 is a lowercase. Now if you have a strange, then you want to convert it to uppercase, then you specify that strange object, and then you add dots, and then you indicate with dot upper. So that will switch it all to upper cases. Okay, so when you issue this command, you realize that it has been changed to uppercase. Okay, now let's do the same for the DNA one. We had this earlier object we created, so let's convert it to a lower case. So to do that, you can just say DNA dot lower. Okay, yes, so that's it. So let's do for the other one too, which was my name. Okay, so this was my name. Now let's convert it to uppercase. So to do that, I'll just say my name dot upper, and that converts it for us. There are other methods for manipulating strings and DNA sequences, but I will show some of them at the end of the session. So let's quickly search and look at how we can convert the length of a DNA sequence. So let's create a DNA sequence. Let's say DNA1 is equals to AGTCC. Now let me just use any random. Yes. So we have created our DNA. So if you want to find the length of a string character, then we use the function len. So in the len, then you put whatever you want to find the length in it, and then that will give you the answer. Okay, so the length of this sequence is what? 19. Now this one can be easily counted. Okay, but if you have situations like this where you have, let's say, you have something like this, then it becomes problematic trying to count it manually. And this is where programming becomes very important, because with programming, with Python, all that you need to do is to issue your len statement, and then it will count for you. That's very, very simple. Okay, so note that the counting includes all characters, including the space character as well. And so if you were to count for my name objects, then it's going to be 13. Okay, why is it 13? Have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 13 characters, including the space character. So that is why it's 13. So Python considers everything in the code as a character. So you can create your own strings and then use the len function to find the length of those characters. So the next session is going to be how we can check for the presence or absence of characters. Okay, so that is pretty simple. So let's just say we have our DNA sequence. Okay, DNA is equals to what? AT gene CC. Okay, so let's just say we want to find if there is what? A T in it. So if you want to find if a particular character or a pattern is in a string, then what we do is to say, if let's say it's A, then we say A in DNA. Okay, so it's true because there is A here. Okay, now let's try another one. Let's say B in DNA. It's false because there is no B here. Okay, now let's also do something interesting here. What about if we say A in DNA? The answer is false. Okay, it's false even though there's an A here. There's an uppercase and the query we have is lowercase. Python is a case-sensitive programming language, and so capital A as an uppercase A is different from a lowercase a, and so that is why we have this answer to be false. Okay, so that's how we check for the presence or absence of characters, okay, in it. Now let's try something longer. So what about if we say AT in DNA? That's also true because there is AT here. Okay, so that's for the presence. I'm checking for the presence and absence of characters in nucleotides, okay, and DNA sequences. Now let's move to the counting of the number of nucleotides in a sequence. So if you want to count for nucleotides, or if you want to count some characters in a string, okay, let's say we have our DNA again. We have this DNA sequence created. Okay. So if you have a DNA sequence, let's say you want to count the number of A's, then we specify the sequence, the strange objects. In this case, the variable name is DNA. Then we add .count. Then we indicate the substring or pattern or nucleotide or character we want to count in it. So once we do that, it will count for us. So we say the number of A's is what? 9. Okay. Now let's make this code much more elegant. So let's just say we want to count for each of the nucleotides. So let's say A count. That's the number of A's because for DNA.count A. Let's say C count because for DNA.count C. And let's say J count because with DNA.count J. It's uppercase. And then let's say T count because with DNA.count T. Okay, so we count them. So now we can actually print them here. So let's say print A count. Okay, and that will give us 9. Okay, we can also make it more informative by adding, let's say, number of A's is equals to, and then we add A count here. Okay, so that makes it more readable and understandable. That number of A's is equal to what? 9. Now, because we've organized this count properly, it's now easy to what? Get the percentage GC, the GC contents of it. So if you want to find the GC contents, what is what? The total number of Gs and Cs divided by the length of the DNA multiplied by 100. So now let's find the Gs and Cs. So that will give us what? G count plus C count. Okay, now let's find the length of the DNA. And that will be what? Len DNA. So now if you want to find the percentage GC, it will be what? The GC divided by what? Length multiplied by 100. Okay, so once we've computed it, we can print GC percent. Okay, that gives us what? 21.74. Yes, so now we have what? Our GC content also being calculated for us just by a few lines of code. Okay, so if you have this situation where you have numerous DNA sequences where you want to find, let's say, the GC content for each of them, then this simple Python scripts can help you get those answers done within a split of a second. Okay, so that's for the counting. Now you can also combine strings and sequences. Okay, so let's just say you have DNA 1 got ATGC and DNA 2 is equal to what? GCCC. Now how do we combine the two? If you want to combine strings together, we just use the plus sign to do that. So let's just say combined sequence. So if you want to combine for DNA 1 plus DNA 2. Okay, so now we can print a combined sequence. Okay, so now we have it. Okay, now it's combined based on the order that you made the entries. So you write the DNA 1 here first and DNA 2, and they were combined here. Now in the process of combining, you can also add some additional characters by using the plus sign, and there are other ways of combining strings, but this is just a simple one to get you started. Now let's try another combination here. This time we will just use two names. So let's say first name Python, second name language. Okay, now let's call the resulting combination full name. So it will be what? First name plus what? Second name. So now we can print it, and that gives us what? Python language. Okay, but when you look at this, it's what? Python language, and there's no space character. Okay, so if you want to do that, we can simply add a space character to it by just saying full name but what? First name plus space plus second name. Okay, there's one way of doing it. Okay, so once you print the full name, now you get it in the correct order. Okay, now there's another way to do this by using what? Strange formatters. These are things we will do at a later stage, but I'll quickly do one of them. So we can say full name is equals to %s space %s. So this means that we are going to input a strange data type. This also means the same, and this space here will be included. And then we say %s what first name and then second name. Okay, so now we can print the full name and that will give us the same thing. Okay, but as you progress in the programming language field, you realize that using the string formatters is way much preferred than using this particular type. Okay, this has a lot of flexibility in terms of how you can handle various strange objects. So if you want to manipulate string, there are tons of functions and methods that can help you to manipulate your strings or your DNA sequences. Okay, but these are just a few of the functions you can apply to manipulate strings, and I'll encourage you to try them all. So we have what? Find the first position of an occurrence. Okay, these are things that we'll be doing as we progress in the course. Okay, so you can start by what? Querying and then practicing some of these functions as well. Okay, so it's very important that you do that. Okay, so finally, I leave you with an exercise that you can try and then get your hands dirty with Python. Okay, so you have this sequence here, and then you are expected to calculate how many nucleotides are present, find the GC percentage, and then find the how many purines are present as well as the pyrimidines. Then you can also calculate the percentage of purines in that sequence. You can do it and then put your answers in the comment section for us to discuss. Thank you for watching, and I'll see you in the next session. Bye bye.